Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, I'm Keith Kaplan, a software architect at Microsoft, and I'd like to welcome you to Behind the Code. In this series, we feature Microsoft employees who have achieved great things. Our goal is to reveal what it takes to create great software as we look at the technology and the person behind the code. For 18 years at Microsoft, Rico Mariani's contagious enthusiasm for technology has inspired countless others to write better and faster code. Most people inside Microsoft know this software architect from his frequent postings on the internal performance tuning email alias, and other people know him by reading his blog on MSDN. He often says that being an architect is a teaching gig, and his passion for sharing knowledge has established him as an industry expert. Additionally, what you may not know is Rico is responsible for many of the cool features and tools that make programming easier, like value tips in Visual Studio. Please welcome Rico Mariani. Glad you could be here, Rico.
Thanks for having me.
And let's start with the pressing question. Tell me about the first time that you used a computer.
The first time I used a computer, well, I get calculators don't count, I guess, so you mean like a real computer. I was in the 9th grade, and they had this Hewlett-Packard thing with a card reader. It ran BASIC, and I wish I knew the model number, but it made the rounds in Toronto. And I was in this math program where, you know, they were exposing us to some enriched stuff, and this was one of the things. And I had a fellow who, for about a week before the computer arrived, taught us flow charting and some other stuff, and the basics of BASIC. And when the thing came in, we were all like filling out these little, you know, bubble carded, you know, like lottery card stuff with basic programs. And we had simple stuff, and we did it all batch, even though it was there, because you didn't want to tie up the console. So you put your stuff in little data statements. And my crowning achievement was this little simulated order entry thing, like where you would say how many of what you were buying, what they costed, and then whether it was taxable in little data statements. And it would make like a little statement, you know, with the total at the bottom, and I was all very excited. And the program ended when it, you know, you had to put little sentinel values in the data so it knew it had found the last one. It was a lot of fun, and it kind of changed my career path, because until then, I thought I wanted to be an architect, like the kind that designs homes. And this like 2 weeks exposure to computers, and I thought, well, you know, I should do this. So I totally changed my high school plans, and I went to see like my guidance counselor, and I said, well, can I mix in some computer science courses and not screw up my long-term plan to be an architect? And he said, yeah, you can make that work. And we made something, and I took everything very seriously. I have a plan for everything, right? So
even in 9th grade.
Even in 9th grade, I had my whole high school career planned out, and I had the whole thing and what I was going to do, and you know, I knew what I was going to be when I grew up, when I was like 2 months old, I don't know. And so I did this. I changed my plan, took some electronics, took the drafting, took the whatever, and threw in a computer science course. And they had us working on PET computers at my school.
That was the Commodore, I think?
The Commodore PET, yeah. A little 8K PET with the calculator-style keyboard. And that was fun. And within 6 months, I was disassembling the ROMs, learning 6502 assembly. I still say that I learned 6502 assembly from Bill Gates.
How's that?
Yeah, well, because the ROMs were Microsoft Basic. And like you could look at 6502 assembly and get the opcodes from the manual, right? But that doesn't teach you how to program. I mean, that just teaches you what the opcodes are. So if you want to look at what are cool ways to combine them, and what's an effective way to do a loop with one register, and what are interesting ways to use the stack, you want to see sample code, right? Mm-hmm. Well, they didn't publish sample code for 6502 assembly, but you could disassemble the ROMs. And so I used to say, well, Bill Gates, this is based on his code. You know, and maybe he even wrote some of it. I don't know. I mean, back then it was like 79, 80. You know, he could be actively coding still. So I used to say, you know, at least by proxy, I learned assembly language programming from Bill Gates in high school. You know, it was fun stuff. You could do a lot on those pets, and they were very understandable, very approachable. You know. And you could really, get to the heart of the matter. Fun stuff. Yeah.
There was a computer store where you used to hang around a lot. Tell me about that store.
Yeah, I worked at ComSpec for many years. I started there by hanging out at the store. It's kind of a funny story how I even started hanging out there. The reason that I was hanging out there was because I couldn't hang out in the computer lab at the school because they had a work to rule that year. And so the teachers were not allowed to keep the place open for extra credit. None of the extracurricular activities were allowed, and they didn't strike, but they did this work to rule. So you couldn't go to the computer lab after school. And I wanted to keep, practicing, and I knew the store was nearby, and they sold pets, and they had several on the floor. And so I'd go there and hang out, and they kind of liked to have someone there using the computers, especially if you didn't intrude with the customers. But, they'd have 2 or 3 computers, so if they had somebody there doing something interesting, it was good for business. And they, over time started noticing that I was kind of consistently doing interesting things, and some of them looked useful. And so they offered me a part-time gig doing computer programming there, and also working the sales floor, by which time I knew a lot about the computer, enough to sell it. And they also sold CB radios and other stuff. They were very good to me at ComSpec.
But they really met you just because you hung out in the store.
Up, yeah.
And eventually they said, we'll put a name tag on this kid.
That's right.
It's either get rid of him or...
Pretty much that. It was a great place. I learned a ton there. Wrote a compiler for those guys. And that led to more stuff. Yeah.
And you went on to university, and by this point you had abandoned the building architect plan and gone with... And where did you go to school?
I went to University of Waterloo, and I had a great career there. I still tell people your college career can be, and we call it university in Canada, but here call it college. Anyway, your college career is what you make of it. You can enrich the program a lot. I mean, if you just show up for classes and do whatever, you'll leave and you'll have gone to some classes. But if you hook up with some of the groups there, and a lot of them are very open. I hooked up with the symbolic computation group there. I did some work for them in Maple. I did some ports for them. I used that to get experience in the Amiga. And then, of course, Waterloo has a co-op program. I did some work for the Science Center. And
so this was one of the internships that you did while you were there?
Yeah, I did 4 different internships. I did internships for ComSpec, too. My first jobs were back at ComSpec. So I left them after and went to the Science Center. Then after that, I landed at Microsoft. I had a great time at Waterloo.
And what was the Science Center? I'm thinking of, for instance, the Seattle Science Center near here, where
it's like the Pacific Science Center. It's a science museum. The Ontario Science Center is it's substantially larger than Pacific Science Center. They do shows every other year. They do a big show, and so while I was there, they did the food show. My first exhibit was about where the food comes from in a Big Mac meal, and so you'd have a map of the world, and you'd guess where they get the ingredients from, and so forth. It was called like How Many Miles in Your Mac or something like that. It was actually on the floor for a long time. They recently retired exhibits from the food show, and then we did some stuff for the sports show afterwards. By that time, there were really good microcomputers that you could buy off the shelf that they could use for exhibits. A lot of these exhibits, they weren't about computers. But they wanted them. They used computer technology to kind of make the point and for teaching. It's a great place because you can't have a bad day at the Science Center. If you're having a bad day, you go upstairs and there's this line of kids that are lined up to play your exhibit, and kids are merciless, right? Mm-hmm. So it must be at least kind of good because they're up there and the kids are like, cool, this is great, and there's like 20 of them waiting to try the thing, and you go back to your office and you're like, this is good, I'm going to do another one, and I'm going to have this sport thing, and there's going to be a line of kids, and great folks. That was my first experience with designers, graphic designers, 3D designers, stuff like that. So I got to meet people with lots of different kinds of training. And that turned out to be very handy at Microsoft when I was working on, say, Sidewalk, which also had a very design-rich environment.
So you're sort of the computer guy, but you're working with non-computer people.
Yeah. You work with people who can tell you where the shadow is going to fall on your display because of where the light's going to be, and they'll coach you as to how you should do your displays to take best advantage of where the light's going to be, because they make it their business to know the 3D space and what the layout's likely to be like. Or copy editors never get too attached to your words, because there were people who were very passionate about getting really good wording and good educators that know how to explain things well, and you just get all these inputs, and like you rapidly sort of become egoless about the little stuff you put together, and you're like, I got to make a platform for these people to get their word out, and if they want to use color, I got to make that possible for them, and I want to be flexible when I go into meetings. I want to be able to keep saying yes, yeah, we can do that, yeah, I can change it, yeah, that's an easy thing to do, and so you want to be agile and be right there. It's really very fun, and lots of different people, different opinions. But really, what makes it fabulous is the kids coming through there and the clients. It's very, very real. A lot of fun.
And after your internships and the rest of your coursework at Waterloo, your first job then was
at Microsoft. Yeah, I started August 15th of '88, and I remember I was in the middle of my compiler project when I came out to interview, and had a great time. Exhausting day. But
what group
really
were you interviewing with?
Well, when you come through as a campus candidate, they don't usually interview you for a specific group. There were multiple teams seeing me, and part of the experience is kind of they're looking for fit, and also you're just a graduate, and so they don't especially think that you are a specialist yet, and that you really should be laser focused on any one group. So. They let me look at a variety of different groups. I talked to the OS group. Well, the job I settled on was in the applications division, in the tools group, working on a compiler for a language called C#. Not the C# not .NET C#, but it was called C#, and it was a little internal thing. It actually had many of the same properties that the C# language had.
Such as?
Even then, well, it compiled the P code. We had the file semantics were the same in that it sort of glommed the whole universe together as though everything were one compiland, rather than having .h files that have to be compiled in order and the meaning is different. This is the bane of C compilers and C# and C++ compilers rather, because you get these bizarre semantics if you include the same file twice. And so more modern
So something
languages,
closer to what we would today think of as namespace in C#.
Very much like that, yeah. And so it had those kinds of rules so that it could do incremental compilations and other kinds of things. But we ended up not going with it because the databases were too big. At the time, we thought that an 8 megabyte database for storing all the data for the program then known as, which became Access, was too much. That was way too much space. It'll never fly, and so we shelved it. And some of those ideas found their way into Visual Studio later, sometimes a little deflated, sometimes changed to be more marketable. You take the air out of the tires a little bit sometimes, and you have to think about what hardware people really have and at what time. It was a good idea, I think, but like sometimes happens, it was a good idea at the wrong time.
Because the hardware just wasn't ready for it yet.
Yeah, the fact that I can say 8 megabytes of database on the on-disk representation, 8 meg was considered to be a lot. Tells you about what these boxes were doing.
That's one picture now.
Yeah,
so.
Yeah, right. I have pictures of my kids that are that big. I used to joke that we have bitmaps in Vista, actually even before that, for the themes. We have single bitmaps that are bigger than all of Windows 3.1 put together, because that's what you do, and you've got the memory now, and people like to have a nice picture, and it's sensible to spend the memory that way. But in Windows 3.1, using a few megabytes for a bitmap, people are like, are you crazy? That's half the box's memory. You can't do that. Things have changed. Things have changed a lot.
Now, over time, you've become an expert on performance matters. Now, a lot of people, we think we're experts on something. How is it that how do you establish credibility that you really are the expert?
How do I establish credibility that I'm the expert? I don't know that I do that. I have a big mouth. It's the truth. I mean, I go and look at stuff, and I've been vocal about it, critical about it, sometimes even, sometimes maybe even too critical. But there's a balance there. I mean, you want people to come to you for advice, and you want them to come more than once, right? It's not, I mean, if you tell them off and say, well, what do you guys know about any of this? No one's going to ask you the second time. That's no good. So you want to coach people, and sometimes a good coach will point out people's faults, but in a positive way, and in a way that encourages them. So you look at where problems are. You go and you educate yourself. You present the material in a way that's easily digestible by people. There's lots of fairly simple things you can do to help establish your credibility, but mostly you establish credibility by doing the work and helping people to succeed, and sometimes folks know that it was you that helped, and sometimes they don't even know. Like, a few folks might know, but sometimes it's very behind the scenes. A lot of what I do is very behind the scenes, so that's okay. It's about making people more productive, and like I often say, it's a teaching gig, right? So you need the tools to teach. and you need the students too, right?
And how is it that was there a moment where you decided sort of consciously, gee, this is the thing I should become an expert on. I should become the perf guy?
I wouldn't say there was a moment. I think sometimes it just happens. I was the debugger lead for a while, okay? The way I got to be the debugger lead was there was one day I was working on my source code browser, and I was using the debugging tools, and they were Windows tools. And they were kind of slow. And it was the debugger expression evaluator for C++. It was an early build, and I said, well, how hard could this be? Let me, it's pretty slow. There must be one function here that's problematic, and it's slow enough that I can probably find it in the debugger. So I'm like, I know how to use CVW. I'll, debug the debugger with my other debugger and see what happens, And so I'm stepping in the thing, and I found a place where they had this, hashing function that was, the table was too small, and so we were getting these really long searches. Great. So I found it, and I made some fixes, and I suggested to the owner, hey, here's what I did, and this seems to help, and here's a couple other things I noticed, and you might want to try to integrate them the next time you do a check-in, which worked out really well, And so after that, people knew that I knew something about the debugger. Okay, and so when they needed someone to be debugger lead for the next version, they're like, well, Rico knows about the debugger, and like, what had I done? I'd done a little bit of work here and there in the expression evaluator.
But you had touched it last.
I touched it last, so, okay, fine. So I knew about the expression evaluator, therefore I was a debugger expert, therefore I should be in charge of the debugger. And it's not, the truth is maybe a little bit more complicated than that, but not that much more complicated. And already, do you see, just even there, I was doing performance work on the debugger. Before that, I'd been doing performance work on the source browser. I got the source browser because the initial implementation was too slow. And so they wanted someone to, look at it and clean it up and finish up some stuff. And the guy who was working on it was going to move on. And this was in, 88, late 88. So I hadn't been here very long at all. And so I did that, and then when we were working on Visual C++, on Visual C++ 1.0, Borland had a great offering, and we needed to speed up our offering to be competitive, and so I was working on the performance of the linker and, eliminating the CVPAC step or folding the code view information management in with the linking so we didn't have to write the stuff and read it back in again just so that we could throw most of it away and then write it back again. And so all this is like, well, he made that faster, he made this faster, he made the other faster, and then I did server work in MSN, and well, of course, we had aggressive throughput goals for these systems, and so I made those faster, and I was working with various other folks in Sidewalk, and sometimes very hands-on, sometimes just managing, and it seemed to be a common theme in my career that I was making everything faster. And when I had an opportunity to work on the CLR in that capacity, I thought, hey, well, this is a good fit, and it's a good team, and it's interesting technology, so I did that, and then pretty soon I was like officially a performance architect, and whatever, the rest is history.
Now, Julie Larson-Green was a program manager in Developer Tools back when you were there originally, and we asked her to describe you.
The thing that makes Rico so successful is that he really listens to people. He really tries to find a solution for the problems and look for the win-win in every situation. So you can go to him with a problem or an issue, and he's always looking at what's the goal, what's the outcome. He really helps you focus, and he really helps you stay focused on customers. And I think that's the reason that Rico has really been able to excel at Microsoft.
I know one feature you and Julie worked on in Visual Studio was the value tips. Now, how did that feature come to be?
Well, the thing about that one is I don't even remember exactly whose idea it was. We were in a room talking about different things we can do in the debugger. Julie was my program manager on the debugger at the time, and I remember I was there with Julie and Brad Christian and myself, and we were talking about improvements we could make. We were kind of frustrated by the fact that you had to click so much just to see a few little values, and we'd already done some things like auto expansion to make that a little bit easier so you don't have to do quite so much clicking, but we really feel it wasn't there. And Brad was talking about different ideas that we could do, and pointing at stuff, and someone said we should do it like a tooltip, and I could not tell you who actually said it. But from that moment, it was actually very well teed up, because I said, hey, I can do this by the afternoon. We had code for figuring out, based on where the cursor's pointing at, what's the XY of that within the document. We had code for finding the word that was being pointed at. We had code for taking that word and evaluating it as a C++ expression and getting the value. We had code for putting up a tooltip and then detecting the thing and putting it away. So I stitched together a few functions that were already just sitting there, all the ingredients gradients were already in the code base. In literally, it could not have taken me more than 45 minutes. And I had it up, I brought it in, and I'm like, look at this. And then when we demoed this, I think it was at SD93 the first time we showed it, it was just phenomenal, the reception we got for this thing, because it's so cool. You just point to the thing and what have you, and it's often typical. Some of the most appreciated stuff isn't actually the hardest to do at all. This was pretty simple once we had the idea. I mean, it was kind of tricky to figure out, okay, well, how long do you linger? And there's not like a button that you point at or anything like that. So you kind of have to figure, oh, it's a word, and oh, it looks like it's an expression, and so you don't want to have tips popping up all over the place. So, okay, plus or minus that, it's pretty very straightforward. We did other things like stitching together call stacks. In the Intel architecture, right, you can't just get a call stack. The frames are all non-canonical. There's like multiple different calling conventions. And so we had other people doing really hard work to put together more stacks in more cases. Nobody noticed. And I mean, I guess they would have noticed if their stacks weren't working, but it's a stack, you expect to get it, and the fact that it was really hard to get it and do it in a performant manner so you could put it in the UI, it doesn't occur to people. But this, it's there, it's immediately valuable, it's I don't know, revolutionary. I don't know if it's a revolutionary. It's a tip, but it's not something people expected, and it was really received very, very well. And it started with just a simple brainstorming meeting about how, we wanted it to be less clicks to look at the XY value of a point. That's it.
After you had been with Microsoft for about 7 years, you made a seemingly radical transition from really deep compiler guts type work to ostensibly working on a website. You went to MSN Sidewalk. What motivated the change like that?
Well, at the time, there were two motivations. First, I like to sort of reinvent myself about that often, so I tend to make a pretty significant change in my career. If you look even further back, if you look at about every 7 years, I've done something different. I think people should make careers that look more like pyramids and less like towers. So you want to try new things and broaden your horizons. And at the end, you can build a very tall pyramid that way because you have experience in different areas. So I wanted something new. I missed my time at the Science Center where I worked with lots of people from other disciplines. And so I wanted to work with people on the creative side again. And I thought, hey, this would be an opportunity for me to work with writers and copy people and graphic designers again, and that'd be kind of a fun experience. And there was an opportunity, and it was working in Melinda French's organization on a project called Cityscape, which became Sidewalk. And we released it. We made several versions. Of course, what did I do? I started working on technology for Sidewalk, right? And I, was one of the Sidewalk technologists, and I created a platform. I say I, but of course there was a whole team involved. I was the first hire in the development organization, so I built a team, an interesting experience in and of itself. And then, made plans, did deployments, got approval from Mr. Gates, who spent a pretty penny on the effort. Another experience that I would encourage people, if you could ever get an opportunity to have an idea and float it by someone and try to get funding, that's quite an experience, very broadening. So
how so? What do you? Is there something you think you learned from doing that there?
Well, there's something about knowing your facts, knowing what's important, understanding what's going to be good for the business and what makes a good business case. I don't know, being in a room with Bill Gates and asking him for a large sum of money is definitely an experience I remember from my career. And he was very good, actually. I thought he asked penetrating questions, and he did decide to fund us. The other thing I tell people is it's easier if they say no, right? Because if he had said no, then we could have said, oh, it would have been glorious, and we would have done this, and we would have done that. It's like it's sanctified. But if he says yes, then you have to build it, and then it's forever remembered for all its warts, right? Oh, well, we did that wrong, and oh, we screwed up this, and
And I gave you all this money,
and he gave us right. He gave us all the money, so he totally put us on the hook, and then we had to deliver. But we did deliver. We had an excellent product, and the funny thing is, we ended up selling Sidewalk, and I think we sold it at a good time. I can only assume, or I really didn't have too much to do with that. It's a business thing. But I never got so many compliments on Sidewalk as the day we turned it off, and so that was kind of nice. That was kind of nice.
I know we worked with Tara Prakriya during your time that you were in Sidewalk, and we asked her about the influence that you've had.
I met Rico many years ago. I was originally the GPM on a team where he was the architect. And I was fortunate in that team to be around so many senior people, Rico being one of them. I didn't realize how fortunate until I cataloged over the years just how many things I've learned from him. And as I mentor other people now in my career, I use Rico as a great example of somebody who has managed to have fantastic scope of authority in impacting projects all across Microsoft, across divisions, across any kind of boundary that most people would find limiting. And he does this because he does the right thing for the project all the time, and he gets people to do the right thing because it's the right thing to do. I often use Rico as an example of someone who is not limited by management authority or positional authority in having the scope of influence that's necessary to make big positive changes across Microsoft.
Now, Tara mentioned mentoring in there, and I know that you act as a mentor to several people. Tell me about that. Should more of us have mentors?
I think so. I think both sides of the relationship are great. There's nothing better for me. And my favorite thing in the world to do is to help people with their careers and just kind of, if you can coach someone. Anytime anyone, wants the help and is in a receptive kind of mood, you absolutely want to capitalize on that. So if someone says, hey, I'd like to come by your office like once a month and talk about how things are going and and see what your perspective might be, and you can give them some pointers, and maybe sometimes they're some good ideas and they fit well, maybe other times they don't especially fit especially well. Maybe you can give them a little different perspective on a problem. It's great for getting a perspective and for kind of calibrating sort of what's normal and what's possible. Because that's another thing. People sometimes they don't know. Like maybe they're shipping their first product and they're like worried about how many bugs there are, and so they come to you and they say, well, I'm worried about all these bugs and we have this, and you can say, don't worry, that's normal. You should have about this many. You should look for a tail off that looks like this. Get worried if it starts looking more like this or more like these numbers. Keep your eye on the code churn or whatever it is, whatever the issue is. So you can bring perspective. Sometimes I just do raw teaching, meaning there's a particular technology a person's not especially familiar with. And so I'll spend, a couple of hours with them, maybe just drawing it out and explaining what the issues are and what's important and what's not important and how they might do an assessment, for instance, in their context. And then contrary-wise, anytime you can get criticism from people, especially, it's the negative feedback that's actually the most valuable, right? I mean, it's always nice to get a pat on the back, but you often don't learn nearly so much from the pat on the back as from, a gentle slap on the wrist, right? To say, hey, that was maybe a little over the top, or, actually, I think it might have worked better if we'd done it this way in retrospect. And you don't have to assign blame. You want it to be very, very positive and meant in a way that's going to help a person going forward. And so I seek it out anytime I find anyone that is willing. I'm always happy to listen and try to incorporate some of what they're saying. And it's okay. I mean, it's all this criticism. You have to kind of take it as sort of optional improvements and sort of incremental things you can do for yourself and for someone else. If you mentor someone a lot, and you make a profound impact on them, that might be like a 1 or 2% change in a year in some direction that they're trying to improve, especially things that are sort of part of their nature, and so maybe you meet a shy person and you're trying to teach them how to be more extroverted at meetings and get their things across. So
you would probably be a good role model there.
Right. Because I'm so shy. Yeah, but the point is, if you're trying to change something fundamental about a person like that, and it's not so much changing, but like giving them tools to cope with that. You think, well, if I can make them 15% better over the course of 5 years, that's a good accomplishment, and that could be very, very useful for them. And so you have that long-term perspective, and you want to be very, you want to be that coach. I really enjoy that, and I think it's important. Yeah.
And when you moved out of MSN, you returned to?
I came back to my roots in the developer division. I was really in touch with that customer. There was a great opportunity on the CLR. I hadn't worked on runtimes. I'd worked on the tool side. I'd worked on virtually everything. I'd worked on the linker, the building system, the IDE, the debugger, you name it. It's pretty much all the aspects on the tool side. But I had hardly worked at all on, say, the C runtime or MFC, a little bit, but hardly at all. And so I came to the other side of the house, the library side of the house, and help them with their performance issues and trying to get a performance culture there, and troubleshooting some particular performance problems too. Like I worked on interop speed, for instance, was one of the things I worked on specifically. I helped the security folks with some, issues of balancing their security needs, which we can't compromise on, and meeting those needs and also getting good performance out of the system. So those very challenging problems, and some brilliant people there. Patrick Dessud, Chris Broom, Sean Turbidge, great guys. You couldn't go 5 minutes without learning, 100 things from those guys. I so enjoyed the architects meetings there. Jim Miller, we were always learning stuff one from the other. Certainly I was learning from them. I certainly hope it was a two-way street. But it was fantastic because there's so much perspective. Many of these people were specialists, and specialists in particular areas, but also generalists. And so to be able to go to a meeting where, someone would be presenting an idea and it could be critiqued from various different perspectives, from a security perspective, from all these perspectives, and, half the time, or more than half the time, I'm just sitting there trying to soak it all up, and then also add something, from my own perspective.
Is that how these meetings go? There's sort of the security advocate, the performance advocate, and this committee of...
Sometimes. Other times people speak one for the other. Many times, and I was kind of happy when this happened, many times people would say, okay, well, Rico hasn't said anything yet, but I know what he's going to say, right? So I'm just going to say it for him. And, and so then they'd ask a performance-related question that was, like, of course, almost invariably the one I was going to ask. Sometimes not, though, actually. Sometimes it was, they had thought of an angle of that wasn't the one I was going to home in on. So that was interesting, too. And so we're trying to learn from one another, and also so that if somebody's not there on a particular day, there'd be someone who could speak intelligently about what the performance considerations might be. For instance, taking my role, but it's very collaborative. It's hard to know what's going to come out because it's hard to know which of the experiences that a person is going to draw on in any given meeting. I mean, all these people had built these pyramid-like careers. There were not any, there weren't specialists. Not any of these people was so specialized that you could say their career looked like a tower. There were no one-trick ponies. Okay, so you just never know what was going to come out of somebody's mouth where he was going to say, well, I remember a problem like that on 360, and actually it turned out that there were, assorted issues, and and this looks very analogous to that now. Okay, and that problem had these gotchas, and this is how it applies to your situation now. Teaching by analogy or by experience like that is invaluable. Most of the time, people came to the architecture meetings. It's kind of like they're looking for a crystal ball to some extent, right? They want to know what's likely to go wrong with what I'm proposing. If anything were to go wrong, what would it be? How do you feel about this? What am I missing? And so they're not so much looking for a pat on the back, although, you'd like to give those too, because sometimes people come in and there's some real gems there where they've solved a problem that looks really hard. And so you want them to feel that kind of, hey, that looks really sweet in this area. Now, but you do have these couple things to look at. Don't let this little thing kill you. You can you can squash this problem. So getting all those different perspectives is invaluable, and just kind of getting the juices flowing, and having people talk about stuff, and also keeping in mind kind of how it fits with our longer term plans, and should we change the investment a little bit so that it lines up with where we want to go, as a company or as a division. Are there other efforts? The architects are often very well connected to other parts of the company, and so if there's significant overlap between this particular product or idea and something someone else is doing, you can say, oh, you should.
So much of what you're doing, you're really thinking beyond how can we do this bit of work so someone could build this thing on top of it, and you seem like you would need to be somewhat versed in what these other things you're building.
That's where that breadth comes in. You want to be thinking about how others could build on what you've done, and you want to make sure you're not painting yourself into a corner gratuitously. A lot of times you can't solve the whole problem all at once. Like, for instance, I'm the performance guy, so let me pick on performance. So you might do version 1 of this thing, and the performance is just not what you want it to be. And you may even know how to make it more performant. But you think, you know what? We can get it to market 18 months sooner if we take, a C on performance instead of an A. Okay? And a C is still pretty good, and a lot of people will be able to use it, and we know how to get that A when the time comes. And so you want to have it teed up so that in the next iteration you haven't, painted yourself into a corner to the point where you now can't do the work without breaking the world or, breaking your customers to make it faster. So sometimes you're looking at it to make sure you'll have future agility, for looking for options.
We can't fix this now, but we have a way out.
Right. Or sometimes it's not a question of fixing it, to say, how do I do this in baby steps? How can I make it so that over the course of 3 releases, I can go from nothing to a basic entry to an entry that is complete to an entry that's complete and performant, and without breaking people along the way. And at the same time, putting useful bits in the hands of your customers. And that's very important, right? I mean, because sometimes if you kept it on the shelf for say the 6 years that it would take to do that, it's a dead idea, and no one would ever want it, or someone else will come up with an incremental approach and their idea will win. And you're like, well, but I knew how to do that. Yeah, well, you didn't release any bits and no one knew what you had and they couldn't start building on it or do anything with it. And
every customer has millions of lines of code written in this other world.
Exactly. And now you've missed the boat. So you have to, you have to time that. But you don't want to put yourself in a position where, for instance, you've made a decision that's, again, sticking with performance, you've made a decision that has basically made it impossible for you to ever get the performance that you want because you did something silly in the early thing. So, looking forward to that future agility is very important too. And that's another thing that folks like to come to you to talk about, to make sure that they're not being too nearsighted.
And I know that
short-sighted, it's a better phrase.
You are the performance guy, so of course a lot of the conversation has been about performance today, but it seems that any time you talk about the CLR or managed code in general, performance is one of the first things that seems to come up. Why is that?
Well, a lot of people worry about the performance of managed code generally. It's a new thing. And people say, well, how could this possibly be as performant? I mean, the compiler's not as good, and I don't have complete control of my memory, and so on and so forth. And so there's a lot of issues. There's a lot of potential gotchas. The framework's big. It's a new thing, and lots of people pick it up, and they don't know what's expensive and what's not expensive. There's decades of idioms where people are used to, when you write C++ code, you write it this way or it's awful. When C++ first came out, there was all kinds of backlash in terms of, oh, don't use that, it's a disaster, don't use that. Oh, this is an awful language. It's so expensive, it's bloatware, crappy, And now all that's pretty much blown over. Why? Because in the course of, say, 10 years, 15 years, people learned about good ways and bad ways to use the technology, and there's this sort of cultural, tribal, if you will, knowledge of how to do good C++ programming. Well, good .NET programming, .NET is like at the beginning of that curve, right? And sure, we have this library, but like, do people really profoundly know what the costs are and benefits and what are good ways to use it? People need time to experiment. So a lot of times when people have performance failures, it's because they're the candy store, right? They just grabbed too much all at once, and then they found themselves overwhelmed, and they drowned in it, and then they failed, and they're like, oh, it's awful. Well, no, it wasn't really that it was awful. It's a combination of, well, some of the stuff is new and could be better. Some of the stuff is just, we don't have that tribal knowledge, and we need to get it. And you put those together.
Well, there is quite a bit of tribal knowledge that you have, that if there's any you'd like to disseminate here, any advice here? How can I not be the one abusing the candy store and writing the bad, slow managed code?
Well, there's a couple of things that I encourage people to do. The first is to have a plan, and that's kind of an ethic, a universal ethic for me, I guess. But if you think you need to use a certain piece of technology, you should know some of the properties of that piece of technology. If you were an engineer and you were going to put up a building, you would be deeply familiar with the properties of steel, profoundly familiar with your raw materials. And you wouldn't just start building, without checking out what the materials were and what their capabilities were.
Well, the distinction here, though, is there are books, just textbooks and reams about the properties of steel. I know where to go look that up.
Yep.
How do I know how fast the array list class is? Where do I start?
Oh, and that's a problem that's near and dear to me. One of the things I'm trying to do is establish this thing I'm calling performance signatures. It's very new. I just spoke about it.
This is on your blog this week,
It is on my blog this week, yeah. And it's about rough costs for methods and kind of showing people where they are in the abstraction stack. Is this thing light, heavy, medium? What the heck is it? I mean, throw me a bone. So if you had a rough idea what things cost, at least you could say, look, okay, my thing needs to be in the medium category, so I better not call any highs. Okay, so that would be something. And you can't even do that now because there are no tomes. But that only gives you kind of approximately correct guidance, and it can prevent colossal mistakes. A lot of times, people blow their performance goals by not 2%, by like 2,000%. So they're off by a factor of 20. You don't need a fine-tooth comb to find these problems. Usually, it's a pretty big thing that's gone wrong, a dependency that they fundamentally couldn't afford. So fair enough, okay, we can prevent some of those. But again, sometimes I say, hey, look, but you don't want to be a victim here, okay? Like that API, I mean, it was expensive the day you started coding. It didn't like suddenly, stealthily turn expensive on you. So the stuff that's going to be critical for you, you can prototype it. You can sometimes you can write a 3-line test to kind of get a feel for what the heck is this thing anyway? Can I use this? Is it suitable? What does it do? Let me look at a trace. And for things that are critical to your success, probably you should do that. And the rough guidance isn't going to be enough. So you want this mix of experimenting, getting to know what's going on. I mean, with structural engineers, how do you find out? If suppose it's an unpublished property of the steel, you need to know some strength that's not there.
I suppose I'd take a small piece of it and subject it to some test.
Yeah, right. So and that would be critical. So you do a proof of concept. Before you build a whole building, if your customer likes it, you build a scale model and you say, well, how does it look? How's the light falling? Is this working for you? Is this kind of what you want? And a lot of times we don't do that. But then some of the things that we advocate, like on the agile side and extreme programming side, they're kind of like, hey, build a scale model. Don't try to solve the whole problem first. You do want to get started and you want to kind of have things that you can show so that you can illuminate these things. But you want to be thinking about these things all fairly early in the cycle and eliminating the big risks very early on so that you can feel more comfortable later on. You don't want to arrive at the finish line and then find out that your substrate was a disaster in the first place or was maybe just not fit for purpose. Sure, maybe it's a fine list class, but it's not designed for use the way you're using it. It was designed for some other use, and it's perfectly good at that use. And so you want to make sure you have that fitness for purpose test very early on. There's lots you can do, simple stuff, to control the risk. I often talk about controlling risk.
I know that early on in the managed code cycle, there were some meetings with some of the senior executives of Microsoft who were less than satisfied with some of the early performance numbers.
Some of the later performance numbers too, I think, as far as that goes. But okay, first, I never want them to be satisfied. I'm never satisfied. Why should they be, right? So, it's always got to be, okay, well, that's all very nice, but what have you done for me lately, right? But some of our executives were especially vocal about things like compiling a lot of code on the client without having a high-performance compiler, highly optimizing compiler, and other things that are fairly radical. And we got into some interesting meetings involving our senior management. Bill was especially critical of some of our work, and so we had a fun meeting. But we really aspire to hit this problem right between the eyes.
Oh, you're changing the subject from the meeting. I need to hear more now.
No.
I'm intrigued.
No.
You're saying that Bill was particularly vocal and unhappy, and so what do? You're sitting there at this conference room. And
I was actually about to tell you what we did to impress him at this meeting. I was sitting. The two performance architects for the CLR were sitting side by side. I was sitting with my colleague Jan Gray. And we were kind of taking questions. We weren't nominally the presenters, but a lot of the questions were performance related. So I'd say we were sitting on the hot seats. And he was asking us some pretty hard questions, which was good. I mean, it's good that he wasn't asking us, dumb questions. So he was asking us these questions, and one of the things he said was, well, what do you even aspire to do with this code? Like, what are you thinking? And as one, Jan and I said, we have to be competitive with Win32, because Win32 is the real competition out here. If we're going to cause a revolution, it has to be as good as native code. There's no question. And he was kind of surprised that we took such a strong position and that we'd be so self-critical of ourselves, right? Because we had a long way to go to get to Win32. And he said, well, don't you at least want to be as good as Java? And I looked at him and I said, we have to leave Java in the rearview mirror, or this thing doesn't fly. And he said, well, aren't you going to look doubly stupid if you don't at least beat Java? And I said, Bill, you can only fire me once. So that pretty much brought the house down, and it was very good at actually diffusing the situation. What I told people about that meeting was it was like Rocky. We were really taking a beating in the first rounds, but by the end, I thought we had him on the ropes. We were doing pretty good, and I think we won him over with how aggressive we were, and I think he at the very least, I'm confident that he was that he thought we had our act together and we knew what our own problems were. There was a couple times where we said, hey, that's okay, you can beat us up about that, but that's not the real problem. Okay, that's an easy one. You should be beating us up about this. I mean, this is even worse, right?
Officer, you want to see speeding? You should have seen the mile ago.
It's exactly right. But it was kind of a good way to get him off something that we thought was not even that important, and we could move the conversation to an area where we really wanted his opinion because we maybe weren't as sure what we wanted to do or what was important to him. And we could say, look, that's forget that one. Let's go over here. This is where the real disaster is. But that's another great way to work with executives. I mean, we're very open kimono. We make it very clear where our weakness is, and we don't pretend to have things under control that aren't under control. We point out our own problems. The last thing you want to do is make it so that some executive blindsides you with a problem, or you're hoping that he doesn't discover it. You just come right out and say, look, here's what's bad. These are the things we have to address. This is what we think the priority is. This is why. What do you think about that? I mean, don't pretend any of this is good. That's not going to get you any points. But it was actually a good meeting. It was a good meeting overall, and funny story. So.
What do you do in your spare time?
Bunches of stuff. I spend a lot of time. Well, I like to read. I like to read fantasy. I like to play certain video games. I play World of Warcraft lately, so that's been kind of fun. But I also do 3D art. You just got my Christmas card.
I did get your Christmas card, and that's your illustration.
That's my little illustration. It's made from pieces. So I spent a certain amount of time shopping for elements that I wanted to use. And then a certain amount of time posing and lighting. It's kind of like photography. When I explain it to people, what you have to do is, you imagine I was a photographer and I know some professional models and they'll come and sit for me, and I have a wardrobe, a variety of clothes that I've bought so I can give them interesting clothes to wear. I have backdrops that I can have, and I have places I can take them, maybe certain parks that I know that are good. I have lighting equipment and cameras and various different lenses, and so I design what scene I want. I hire hire the actors to come in. I get clothes from my wardrobe or buy new clothes, and then I pose and light, and then I take various shots from various different angles. And that's kind of what the experience is, only the actors are virtual, the clothing is virtual, the materials are virtual, and they never move. They're great. When I say hold it, they sit right there every time. It's perfect. Even though the render takes 8 hours, they never blink.
They hold the pose
for
the whole 8 hours.
The whole 8 hours. So that's great. And I think it would be really hard if the camera exposure times were 8 hours. That would not be good for the modeling industry. So thank goodness film is faster than that. But that's kind of what it's like. It's a lot of fun. I do poetry. I write poems here and there for fun. I like, strangely enough, I like very structured, complicated rhyming scheme kinds of poetries. I think it's, I don't know, it's parcel of what I do. I'm so used to being shackled, but I'll shackle myself with a bunch of rules for the poem and then say, okay, now that I have to rhyme every other line and have 22 syllables and all these other whatever pattern I want, let's see if I can make something pretty with those rules. It's kind of like when an artist carves something out of marble. It's beautiful, but the fact that they did it out of marble. I mean, it's not easy to work with marble. Every little chip, it's very hard. If it's Play-Doh, you're like, well, okay, whatever, it's Play-Doh. If you make a mistake, you can take it off, stick it back on, but marble, right? So I kind of try to do the same thing. Very structured poetry. Go figure, I take a structured approach to poetry.
Everything's indented
indented just so, yeah. But some of it's okay. What I say about my poetry is the same thing as I say about my art. I'm not saying it's any good. I'm just saying I wrote it.
I asked what did you do for fun, not what will you do as your second career. So.
It's not really, yeah. I don't think any of the poets out there need to worry. I wouldn't be concerned. Any professional writers.
Do you read this to the kids? I know you have.
Down to Red Alert. Some for my kids. I write stories for my kids sometimes too. Sometimes for my kids, sometimes for my wife, sometimes just for myself. I made a lovely little poem for our 15th wedding anniversary. Well, I thought it was kind of nice, but
you don't have to share it.
I don't. Yeah, you're not getting that one.
Now we are intrigued.
Well, it was rated G.
Rico, we have a few questions that we ask all of our guests, and the first one is, What advice do you have for someone in this field?
Well, I think I talked about it a little bit in the session. I tell everyone to be deliberate about pretty much whatever they do. A friend of mine, back when I was in the 10th grade, we were talking about how to write good computer programs. I was writing little games for the pet. And he said, how do you do it? And I said, I just make a plan, you know, and really, I guess that's it. In 3 words, it's make a plan, whatever it is. You know, make a plan for your performance, your security, whatever. You know, I talk about performance a lot, but really it applies to whatever dimension of greatness you want your software to have or your career to have, for that matter. Make a plan. That's it in 3 words.
How would you describe your work to someone who is not technical?
I actually do that a lot. I do it for my kids, and I make metaphors. The one that I use most recently is, I say, look, if we want people to be able to like slay dragons, you know, with Microsoft software, okay, or with software generally, and you say, well, okay, I work on tools, so it's not. I don't even make the swords that you use to slay the dragons with, right? Because like other people are making the swords, right? The software. I make the forges, right, for making swords, and also I teach people how to make a good sword and how to, you know, make a good forge and how to buy a forge, and I make my own forges, and so we create this whole ecosystem like that. So it's sort of indirect, you know. That little story I just gave you is actually how my daughter explained it to somebody else a few months ago, and it's a nice little analogy, I think.
Now, you may have just answered this, but in life, what would you compare to producing software?
Well, I'll tell you my analogy now that I told you my daughter's. Suppose you're Microsoft, okay, and we're making tools. So we want to encourage people to make furniture, okay? So I give them tools for making furniture. Now, we also have a lucrative home business, right? Okay, so we sell houses, but we want those to be furnished houses, and we don't sell furniture, okay? So, or well, sometimes we actually do sell some furniture, but we want other people to be able to create and sell furniture too, because maybe we only make beds, and you know, people need couches and chairs, and you know, we'd like the chairs to work under any table. You see what I mean? So there's all these metaphors of interoperability and getting parts and furnishing a whole home to come up with a solution. And okay, we build houses. That's say windows, right? We build, you know, king-size beds. That's say office. Okay. But there's tables and dressers and all kinds of other things that need to be decorated, and there's good ways to put those together. So that's kind of, you know, there's an ecosystem there. Do you see the kind of the ecosystem? So homes and home furnishings have the same kinds of properties, and dragons too. Yeah.
You know you're a computer nerd when?
Oh, that's a good one. I got the new version of Windows Vista, and the first thing I did was I looked at Perfmon and to see if it was any cooler. So that was definitely a telltale sign that I had gone to the dark side.
We'd like you to draw your favorite data structure and sign your name to it.
Well, I should be happy to do that. Okay, it's actually pretty simple. It's called a Bloom filter, and what you do is you kind of use it to summarize truths, okay? Things that you know are true. It doesn't really matter what those things are. We used it in a build system to represent dependencies. So the truth in that case would be a dependency. So you'd have your truths. I'll just call them, you know, T1, T2. There'd be bunches of them. And then you don't want to remember all the exactness of what's true. So you summarize it. So you make a bunch of buckets. It's like a little hash table, and there's a 0 or a 1 in each bucket. Okay, and the way it's set up is, if something is true, there'll definitely be a 1 in the bucket. Okay, like this. There'll definitely be a 1 in the bucket, and this bucket might correspond to truths from here, a bunch of places. Now, these truths could be very complicated, but I've summarized them with just the 1 bit. So if I want to know if fact 3 might be true, I can look here and say, okay, fact 3, I use a hashing function. So let's call that, you know, hashing of the truths. Tell me which bucket to look in. Fact 3 should be in bucket 2. If there's a 1 here, then it might be true. And then I can go do extra work to see if it really is true. If there's a 0 here, then I know it can't possibly be true. So there's a possibility for false positives here. So that's really good because you can compactly represent stuff, especially where the truths are sparse. You know, so with dependencies, there could be gajillions of dependencies possible, but the actual number of dependencies might be very small. So you can very quickly determine what's a candidate. Okay, so that's it. It's called a Bloom filter. It's very simple. And you wanted me to sign your name
to it. It's me. Thanks, Rico. Now we have time to take some questions from the audience that's here as well today.
Okay.
Okay. For someone who is just right out of college and starting to write production quality code, what are the first things that you want them to remember about performance? Like, what are the few basic commandments that you should never forget, like particularly for the starters who are trying to write good performance code?
Okay, the 10 commandments of performance. That's easy. The 10 commandments are measure, 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 measure. How many? Measure, 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 measure. That's, So at the end of the day, I tell people that engineering is a quantitative discipline. If you're not measuring, you're not engineering. So I don't know what it is that you're doing if you're not measuring, but it isn't engineering. So think about it, and then you think, well, what should I measure? And the beauty of saying just that simple thing, measure, is that it inspires all these other questions. Oh, I'm supposed to measure. Rico says measure, measure, measure. Well, what should I measure? What's my critical resource? I guess I should measure that. What's my customer goal? Do I have a goal? Do I know my goal? Oh, I don't know my goal. I better find out my goal. So all these collateral things kind of step into place when you start thinking about it as an engineering problem. The other thing is, I guess in a production environment, this is really important. You have to plan on imperfection. You're never going to be able to make the perfect product. And so if you go into it thinking, okay, my product is going to have flaws. So, because any engineered thing has flaws. So, well, I better control those flaws. Like I better know what kinds of flaws I'm going to have and that those are okay. And I better know what my tolerance is. You see how the moment you start thinking, oh, my thing is going to be imperfect, it puts you in this great mindset of, oh, since it's not perfect, I better know how imperfect it is and what imperfections it has, and I better be okay with those. Whereas if you go into it thinking, oh, I'm going to build the ultimate piece of software, it's going to have 0 bugs, it's going to have every performance thing, you could think, I'm not going to be done until it's finished, and then you delude yourself into thinking that, I'm going to ship this perfect thing, but it's never perfect. And at the end, you find you've not made deliberate trade-offs about what kinds of imperfections you can tolerate versus what kinds of imperfections you must not tolerate. So all this stuff comes back to taking an engineering approach and just go into it that way. What are my goals? What do I need to measure? What do I need to control? And where are my risks and where aren't my risks? And that applies. I mean, you said performance, but you could have said security. I would have said the same thing. You need to know what your goals are. You need to have a threat model. You need to understand what the risks are. You could have said mean time to failure. You could have said reliability. You could have said maintainability. My answer would have been the same. Have a plan. Understand what kinds of faults you can tolerate, what kinds of faults you cannot, and have a way to demonstrate that you're at the outset substantially likely to meet that plan, and at the end that you really did. And then take risks along the way when you have to, but be deliberate about those. I can take this risk. I don't want to take that risk. This I must control. This is okay to have this much slop. So if you get out of that, it's perfect.
Thank you, Rico, from the Technical Community Network, for being our guest today. And thanks to all of you in the audience for coming.